Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hi there, hello, lesson 31, using trigonometry to determine area. Okay, classwork opening exercise. 3 triangles are presented below. Determine the area for each triangle if possible. If not possible, find the area with the provided information. Describe what is needed in order to determine the area. So first of all, do you remember from your prior math courses, hence 8th grade, possibly others, what is the area of a triangle? So I'll write the formula up here. Area equals 1/2 base times height, because a triangle is half of a rectangle. So if I continued this side up here and then over here, then that would be a triangle ABCD, and it's cut in half. So that's area of a rectangle is base times height, and a triangle is half of that, for a quick review. So area equals 1/2 base times height. I do not need to know the hypotenuse to find the area. So if I write the formula, which I always recommend you do, write the formula, substitute the givens. My base in this case is 5, and my height is 12. Okay, and then my area equals, well, it's a lot easier to get rid of one of the even values when you're dealing with halves. You can take half of an even number. So if I can get rid of this 1/2 by getting rid of this 12 and making it 6, because half of 12 is 6. And then my answer is simplified, and then I take 6 times 5, and it is 30. So there's my answer. Okay. Part D, or triangle DEF, I mean. All right, this one here isn't very clear. Is DF 20, or is from this point here to F 20? I would say that DF is 20 because they didn't name the altitude's intersection point with the opposite side. And I don't know the measure of angle E. So we would have to set this up and try to perform some sort of proportion. So if the whole thing is 20, then is there any way I can tell what any of the other parts are? This does not look like a right angle, and we cannot assume that. So let me think about this. Okay. So if we turn a triangle on its side like this and draw an altitude, well, that is our height. And if this whole thing, if they're meaning this whole thing is 20, then that's our base, and there's our height. So let's use this formula. Area equals 1/2 base times height. Write the formula every time. It's a way to remember the formula. And then 1/2 B. And it's also handy when you're given some other value like the area and they ask you what the length of the base is. If you write the formula, substituting and simplifying will give you the unknown variable. So it's a good practice to write the formula every time. B is 20, H is 8. So whenever I have 2 even numbers, I always like canceling the bigger one because smaller numbers are easier to deal with. And 10 times 8 is 80. So the area of this triangle here is 80. Now on this triangle, I don't know that H is a right angle. If I drop, if you want to call it that, if I drop a perpendicular to H, okay, if I draw an altitude and make this two right triangles, like this diagram here, I do not know the height. I know the base. I don't know this piece, and I don't know this piece. X, this is X, this is Y. There are 2 unknowns. X plus Y does equal 15, but if X is 3, then Y is 12. If X is 4, then Y is 11, and so on and so on. There are infinitely many solutions, and we cannot avoid the fact that there are decimals in mathematics. So there are infinite solutions to this setup. So I do not have enough information to find the area of this triangle. Okay. All right, so without further information in that last one, there is no way to calculate the area. That sometimes does happen, and the answer is not enough information. Okay, page 2 brings us to example 1. And in this problem here, it says to find the area of triangle GHI. So you might think, well, the height, if I rotated this, the height would be 12 and the base is 7. So it's 12 times 7 divided by 2. No, it's not. The answer is not going to be 42. The reason I'm saying that is because you cannot assume this is a right angle, and we cannot call something a height unless it's perpendicular to the base. So we have to draw. So that's what we had here. Okay. If I draw perpendicular to the base, then I make two right triangles. We did not know angle H here was a right angle, so that's why we drop an altitude. We will have to do the same here. So let me do that. Let me draw an altitude down from H to GJ, like so. And then I will mark that as a right angle. So now I have two right angles, because this is right also because that's straight line. All right, this is the hypotenuse of the small triangle, 7, and 12 is the hypotenuse of the bigger triangle. Now this whole side is 15. So before, in the last problem, I said this would be X and this piece over here would be Y. Do not write this, please. So X plus Y equals 15 is not incorrect, but it's not helpful. We have two unknowns. We want to represent a length of one of the sides as one unknown, one variable, not two. So that is possible because if we call this J, and let me get rid of this X and Y here. So we're going to call that point here J. Right there is, so GJ. So follow along here. Segment GJ plus segment JI equals the whole thing, segment GI. Hopefully you agree with that. This piece plus this piece equals the whole piece. If you walk from home to school and then from school to a friend's house, then the distance is the full distance from home to school and then to the friend's house, total distance. Okay, same thing here. So if I call GJ, let's use green, X, GJ is X plus JI, I need to call that something, but isn't JI the whole thing minus the piece? In other words, if GI is 15 over here, wouldn't this piece, if this were 5, this would have to be 10. 5 plus 10 is 15. And 15 minus this 5 would give me that 10. So I could call this 15, the total, minus the other piece. So if I plugged a 5 in here, that'd be 10. 5 plus 10 is 15. If I plugged a 1 in here, this would be 1. This would be 15 minus 1, or 14. 1 plus 14 is 15. So it works for every value of X if you do it this way. So there is my representation. This piece is X, and this piece is going to be 15 minus X. Okay, so now with that said, we're going to do the Pythagorean theorem and try to find our height H. So if I write the formula a squared plus b squared equals c squared, and call our a our base, so that's going to be x squared, and b is our height, h squared, equals the hypotenuse, 7 squared. So that will simplify to x squared plus h squared equals 49. Subtract x squared from both sides, and I get a representation of h squared, our height, which we're trying to find, as 49 minus x squared. Okay, so I'm going to do the same over here. So let me erase this now. That was just to explain parts of a whole add up to the whole. All right, so now we're going to find the area of this triangle over here. Let me use green since I labeled this green all right here. All right, so actually, no, let me use purple. I haven't used that yet. All right, The other triangle, again, I'm going to repeat a squared plus b squared equals c squared. And over here, I called a my x term. So in this case, a squared is going to be 15 minus x squared plus h squared equals our hypotenuse 12 squared. Don't forget when you're doing this, it's very easy to distribute and say that that is 225 minus x squared. But remember, something squared means something times itself. And we have to do FOIL. So we get 225 from our first term. We get minus 15x from our outside term. We get minus 15x from our inside term, giving us a total of minus 30x. And then minus times a minus is plus x squared. So this right here is 225 minus 30x plus x squared. And then h squared is going along for the ride. And 12 squared is 144. All right. So now we want to solve this for h. So I want to move everything over to the other side. So I'm going to subtract 225 and I'm going to add 30x and I'm going to subtract x squared. Okay, so this is going to be minus 225 plus 30x minus x squared over here. And these cancel, these cancel, these cancel, and I get h squared equals 144 minus 225 is negative 81 plus 30x minus x squared. So we end up with a quadratic here. Okay, so now we have two terms that are both equal to h squared. So now if two things are equal to each other, or I'm sorry, if two things are equal to the same thing, they are equal to each other. This is the transitive property, or you could think of it as substitution. Substitute h squared, which is all of this, in over here, or vice versa. Okay, so what we're going to end up with here is going to be 49 minus x squared equals h squared, and this is my h squared in terms of x, minus 81 plus 30x minus x squared. Well, if I have a minus x squared on both sides, they cancel. So that was easy. If I add 81 over to the other side, which I will do, that will give me 130 equals 30x. Divide both sides by 30, and I get x to equal 13/3. Okay. Whew. All right. Okay, so x equals 13/3. I just flipped sides. That's fine. You can do that. Okay, symmetry. So anywho, x is 13/3. Well, that is our GJ. So we know that that's 13/3. So now I can find the height of my triangle without even calculating this, but I could also calculate this, which I will. So let's find JI now. So JI equals 15 minus x. JI equals 15 minus 13/3, right? X is 13/3. I cannot subtract these unless I have common denominators. So I need a denominator of 3. So that was tripling 1. So I need a triple 15. So that'd be 45 minus 13/3. So JI equals 45 minus 13 is 32/3. Okay. 32/3 and 13/3. That's this piece and this piece. So 32/3 plus 13/3 is 45/3, which is 15. So there you have it. I mentioned earlier, these could also be fractions or decimals, and boom, there it is. All right, so now what? We haven't found the area of the triangle yet. We can find the height now, though, because of the Pythagorean theorem. So now again, the Pythagorean theorem is a squared plus b squared equals c squared. And my a squared now is my x. So that would be 13 thirds. I chose the smaller triangle because it's easier to deal with smaller values. Plus b squared, which is my h squared, equals 7 squared. So 13 thirds squared, 13 times 13 is 169 over 3 squared, which is 9, plus h squared equals 49. Okay. So if I think of this as multiplying everything through by 9, I can do it this way as well. I get 169 plus 9h squared equals 9 times 9 is 81. 9 times 4 is 36 plus 8 is 44. I get 441. Subtract 169 from both sides, and I get 9h squared equals 272. Let me make sure I'm doing this right. On clear. 441 minus 169, enter. 272, okay. Divided by 9, and therefore h equals 9 times 3 is 27. It won't go into 2. It's going to be a decimal, so let me just save time here by dividing by 9 and hitting enter, and it's 30.2 repeating. Okay, 30 2/9. Okay, so there's h. Now area equals 1/2 base times height. This was a long problem. Area equals 1/2 the base, which was, remember, the whole thing we're talking 15, times the height, which is 30 2/9. Which is 30.2 repeating. So when I get that, I'm not going to round in my calculator because it'll be more accurate if I don't. I multiply that by 15, and then I divide it by 2, and I get the area to be 226.6 repeating. So it's 226 2/3. Okay, so the area is 226 2/3, and we don't have a unit of measurement, so I would say units squared. And there is the area of triangle GHI. Okay, I just realized something. I realized I made a mistake. I was like, how can this be such a height of 30? That's longer than 12, and that's longer than 15. It doesn't look right. So let me just erase these last couple pieces. I apologize for this error, but it'd be better than me not. Okay, I didn't finish. What did I forget? Hopefully you follow along, and when you follow along, you catch things like so. What's that right there? These 9s canceled. That's h squared equals 272 over 9. Okay, and I'm going to do this a little differently. I'm going to do this as, I'm going to leave it 272 over 9. And then I'm going to take the square root of both sides. So h equals the square root of 272 over the square root of 9, which is 3. And 272 with a factor tree is 2, 1, 3, 6, 2, 6, 8, 2, 3, 4, 2, 1, 7. 2 times 2 is 4. 2 times 2 is 4. That is 8 square root 17. So h equals 8 square root 17 over 3. I'm sorry, not 8, 2. Long day. 2 times 2 is 4, not 8. 4 square root 17 over 3. That is the height. So now area equals 1/2 base times height. So that'll be 1/2 the base, which was 15, times the height, which is 4 root 17 over 3. And I can cancel this half with this 4 and make that a 2. So my area is 30 square root 17 over 3. And then the 30s reduce, and my final answer is 10 square root 17. And since I don't know the unit, I will say units squared. Okay. Okay, example 2 says a farmer is planning how to divide his land for planting next year's crop. A triangular plot of land is left with two known side lengths measuring 500 meters and 1,700 meters. What could the farmer do next in order to find the area of the plot? So under these circumstances, I would draw a triangle. Okay, like so. And I don't know, rotate it, whatever, like we did the last problem. Have it something like this. Okay, so there's my diagram. And let's call this 1,700 meters. And this is 500 meters. We don't know that's a right angle, so let's just leave it at that. A rectangular plot of land left with two known sides length of 500 and 1,700 meters respectively. What could the farmer do next in order to find the area of the plot? Okay, so I put down here, he can either measure the third side length, apply the Pythagorean theorem to find the height of the triangle, and then calculate the area. Or he could find the measure of the included angle between the known side lengths and use trigonometry to express the height of the triangle and then determine the area of the triangle. So what I'm saying is one of two things. Let's see, switch to pen. How about red? One of two things. We could, what is this doing? We could erase this because I don't want it. Delete. Pen, red. We could find this side here by measuring it and then use the Pythagorean theorem, provided this is a right angle. We weren't told that. The other thing we could do is measure this angle and drop a perpendicular. If we knew this was not a right angle, by the way. So those are the two options. If you know that's a right angle in your field, great. Find this side length and do the Pythagorean theorem. And that's how you'd find that third side, by doing the Pythagorean theorem. If you did not know this was 90 degrees, you could use this angle measure and use this as a right angle, or put theta over here even, not here because I don't know any sides over here, and calculate this somehow, and then do adjacent over hypotenuse. Okay, or something like that. So that's what this is saying. Those are the things we could do. Measure another side, or measure the angle and use trig, or use the Pythagorean theorem. Okay, page 3 is an exercise, part A and part B. So pause the video, see if you can do this, and then we'll take it from there. So here we go, exercise 1. A real estate developer and her surveyor are searching for their next piece of land to build on. They each examine a plot of land in the shape of a triangle ABC. The real estate developer measures the length of AB and AC and finds them both to be approximately 4,000 feet. And the included angle has a measure of approximately 50 degrees. The surveyor measures the length of AC and BC and finds the lengths to be approximately 4,000 feet and 3,400 feet respectively, and measures the angle between the two sides to be approximately 65 degrees. Draw a diagram that models the situation, labeling all lengths and angle measures. Okay, so let me get a ruler and a protractor. Okay, so let's move this out of the way. First thing we want to do is draw a side. And 4,000, I'm going to use centimeters as 1,000 feet. So what does that mean? So let's start right here. The real estate developer measures the length of AB and AC and finds them both to be approximately 4,000 feet. So they're both the same. So let me use the same color. So AB and AC are 4,000 feet. Okay, so if I'm going to use 4 centimeters as 4,000 feet, so each centimeter is 1,000 feet, then I would draw segment AB as 4,000 feet, like so. So I would put a dot here and call it A. Put a dot here, call it B, and label it 4,000 feet. Okay, there's AB. And then I need a 50-degree included angle. So the angle between them. So we're doing AB and AC. A, I said twice, A is the angle name. So it's going to be at A. And I need a 50. So let me put that right on as close as I can, right here at the end of that red segment we just drew. Right about there. 50 degrees is right here, somewhere up here. So there's the dot I made. There's my 50-degree angle. So I put my ruler here. I line it up with the 2 points as close as possible. And I'm going to use red for this as well because it is also 4,000 feet. So from here up to 4 would be the 4,000 feet, like so. So then I put a dot here and call it C. And this is also 4,000 feet. And this is 50 degrees. Okay, you with me so far? That's that one sentence. So there's my diagram. AB is 4,000, AC is 4,000, included angles 50 degrees. Done. The surveyor measures the length of AC and BC and finds the lengths to be approximately 4,000, which we already knew from the first sentence, and 3,400 feet. So now if I take this and put that at 0, I should only get to 3.4 if they named this properly or labeled it properly. So I'm going to draw this in green. And as you can see, 1, 2, 3.1234, and sure enough, that is 3,400 feet, with centimeter being 1,000 feet and a millimeter being 100 feet. So it's 3,400 feet. And measures the angle between the two sides to be approximately 65 degrees. So we're talking AC and BC. What letter did we say in both? C. So now he's talking about this angle here and measured it to be approximately 65 degrees. So then I rotate this. I'm going to check. Rotate this around. Put the crosshairs right on C. Rotate this so that the line is right on AC and bring this, hello, let me switch to my arrow. Bring this around to here and look where it ended up. I'm right on BC and we are at 65 degrees. So that is correct. That is 65 degrees. Okay, so it says draw a diagram that models the situation, labeling all lengths and angle measures. So there it is. We are done. There's our diagram. We have a 3-sided triangle. We know the lengths of all 3 sides. And we know that this is 50 and this is 65. That adds up to 115. So this has to be 65 degrees. How do I know that? Well, 2 reasons. Triangle sum theorem says that the sum of the angles of a triangle are 180 degrees. So 50 plus 65 is 115. So I needed 65 more to get to 180. And the other thing is 4,000 feet and 4,000 feet are congruent. So opposite angles are congruent. This is an isosceles triangle. So there's part A. Part B, the real estate developer and surveyor each calculate the area of the plot of land and both find roughly the same area. Show how each person calculated the area rounding to the nearest 100. Redraw the diagram with only the relevant labels for both the real estate agent and the surveyor. Okay, so what's happening here is we have 2 people examining a plot. So let me undo some stuff here. All right, so the first thing I'm going to do is I'm going to delete this, and this. So this was one triangle. So I'm going to copy that. Bear with me. Okay, so down here in B, I just copied my diagram from up here, but then I labeled what the developer and the surveyor found. So recapping this, the developer measured two sides, AB and AC, to be 4,000 feet and the included angle to be 50 degrees. So there's the diagram that the developer came up with. And the surveyor measured AC to be 4,000 and BC to be 3,400 and the included angle to be 65 degrees. So here are our two diagrams. And we want to calculate the area of both. So what I'm going to do is, since they're not right triangles that we know of, then we are going to calculate using an altitude. So I'm going to draw an altitude from C down to AB. Let me make that perpendicular, like so. And I'm going to do the same thing over here. And you don't want to cut the angle, you know. So I will come from A over here like so that it is perpendicular. So there are our two diagrams. Okay, so now I'm going to calculate the area now that I know that this is 90 degrees, and we are going to say area. So I'll do it right here. Area equals 1/2 base times height. I don't know the altitude. I know the base is 4,000. Okay, so if we use trig, all right, let me think about this. I haven't discussed how we can use trig here. So, okay, so here's where I'll introduce a new concept. So I'm going to do it right here. If I have area equals 1/2 a base, times the height, h, 1/2, let's just say this is side A over here. My altitude is side A, right? Here's angle A, the opposite side is little a. So area equals 1/2 a times h. And so if I were looking at this triangle here, the height could be, is the side that's perpendicular to A. So we could call it AH, we could call it CA. So in any way, A equals 1/2 base times height. So then if I introduce the side opposite as B, so here, let me draw a diagram for this. If I had a triangle, let me just draw a quick triangle, like so. All right, and I name it ABC. Then this is side A, this is side B, and this is side C. So 1/2 base times height. So I want the height to not be A. So if I drew an altitude from A, what just happened? If I draw an altitude from A, that's perpendicular to side A or side BC, then that would be my H. So I'm taking the opposite side, A, which would be, let's call it this piece, 1/2, call this little piece A. That's where that A is coming from, and H is here. So then I'm still going to have 1/2 AH, but I want to introduce side B somehow. So I'm going to put B over B. Well, anything divided by itself is 1. So I'll multiply that by the length of side B, which is here. If it were 4, 4 over 4 is 1. But then if I switch H and B, here's what's going to happen. A equals 1/2 A. Bring this B over to where H is and bring the H over on top of B, which we can do, okay, by the commutative property. And so this is still equivalent to the previous line here. Now I have 1/2 AB times H over B. Well, what is H and what is B? it's adjacent, or it's adjacent over hypotenuse. Okay, so the other thing I need to do is, what's my reference angle? Let's call this theta. So H is opposite, B is hypotenuse, OH, opposite over hypotenuse, is sine. So it's going to come out to be A equals 1/2 A times B times the sine of C, or theta in this case. Let's just call it theta for now so we don't confuse. So area equals 1/2 AB times sine theta. So what we're doing here is we're taking an altitude, calling it H. So let's recap. Area equals 1/2 base times height. I'm looking for the area of this little triangle. Area equals 1/2 base times height. Then I introduce the hypotenuse over hypotenuse, which is equal to 1, because anything divided by itself is 1. And then I switch the B and the H. So now I have A equals 1/2 the opposite over hypotenuse times H over B, which with this being theta is opposite over hypotenuse, which is sine of this theta angle. So I get area equals 1/2 the adjacent side to the reference angle times the other side that creates that angle. So if you have a reference angle, it's the two sides that create that angle multiplied times the sine of that angle, and it will give you the area of the triangle. And that's what we're going to do down here. So area equals 1/2 base times height, and then we're going to say, well, here's our 50-degree angle. That's our reference angle. So we're going to multiply. Notice up here, AB, it's the two included sides of the reference angle. So area is now going to equal 1/2 the two included angles times the sine of that reference angle, 50 degrees in this case. And that's going to give us an area. So 1/2 of 4,000 is 2,000. So my area is going to be, let me open my calculator up, and it's going to be 2,000 times 4,000 times the sine of 50 degrees. And that will give me 612,128,355. 128,355.5 feet squared. So there's the area of this triangle with those two sides being 4,000. Okay, so now we're going to do the same over here. So the formula is area equals 1/2. But now it's going to be what I would say side times the sine of the included angle. Okay, so area equals 1/2 4,000 times 3,000 times the sine, in this case, 65 degrees. Now, when calculating that, I can get rid of this 1/2 and change this 4,000 to 2,000. I get my calculator and I do 2,000 times 3,000 sine 65. And I get 5437. So the area equals 5437. Oh, I made a mistake. It's not 3,000, it's 3,400. So let me just change this one value. Okay. It is 3,400. So I've done everything up to there is okay. So let me just get rid of this. Okay, so this is still reduced to 2,000. So let me clear that and do it again. 2,000 times 3,400 sine 65. And I get 61628. 61628 and 92.9, 92.9. This one was 6128355. This one was 6162. So this one was more, and that was also square feet. Okay, so there we go. There's our two calculations. So the developer got this square footage, the surveyor got this one, and they were off by 40,000 square feet. Okay. And then part C says, what could possibly explain the difference between the real estate agents and the surveyor's calculated area? Okay, so the difference in the area of measurements can be accounted for by the approximations of the measurements taken instead of exact measurements. Okay. Okay, page 4 brings us to the end of lesson 31. Before I say just go to your problem set, look at number 1. And from what I just showed you on the last side, you have two sides and an included angle. Whenever you have SAS, side times sine theta. So this 12 times 9 is 108. So if you just put 108 sine 21 in your calculator, that is the area of this triangle. Go to your problem set.